This is the lecture video over your topic 10.1, which goes with your assignment number 23. We're going to start talking about in the chapter 10 stuff about solving quadratic equations in different ways. In this lesson, you learn two different ways. We learn solving quadratic equations by factoring and also solving quadratic equations by using the square root property. We've already actually solved quadratic equations in previous lessons. Factoring is the best way to solve a quadratic, in my opinion, if the polynomial is factorable, which is not always the case, but if it is, it's the easiest. So what we want to do when solving a quadratic equation, remember a quadratic equation, actually, just a reminder, is if you have like an x squared in the equation. Okay, that's what makes it quadratic. So that means there's going to be at least two solutions because of the exponent 2. Sometimes quadratic equations may be like x to the third, which would be maybe like 3 solutions, okay, because the biggest exponent, that would be a 3, or your leading exponent if it's written in descending order. And so a quadratic just indicates it's not like x plus 2 equals 0. That would only be one solution. A quadratic is x squared. So one method is solving by factoring. And the first thing you want to do in factoring is make sure it's in what's called standard form. That means everything on the same side. Here it says left side. It could be, or the right side. But basically you have everything equal to 0. And so like in this case, that's equal to 0. It also could be written, like I said, 0 equals 7x squared plus 56x. Just that one side's a 0 and all the other terms are on the opposite side. And so when we look at this, we have to ask ourselves, how does this factor? There's only 2 terms, and I already noticed that they both have at least x in common. And if you think with 7 and 56, both of those could be divided by 7. So there's a GCF of 7x that we could pull out from that polynomial. Okay, so when we do that, remember you divide by 7x. So 7x squared over 7x is x, plus 7 goes into 56 8 times, x and x 0 out. So then we're going to set those factors equal to 0. Since this has an x with it, it's a GCF, it also gets set equal to 0. Okay, I'm going to just put a line down to show you that it is a factor. We're going to set it equal to 0. And the x plus 8 gets set equal to 0. So this is technically called the zero product property. So you set each of those factors equal to 0. Let's just say for a minute that when you pulled a GCF out, if it was just the number 7, there wouldn't be a variable. So there's nothing to solve there. But because the GCF had a variable, we have to set that equal to 0. So we divide by 7, so x equals 0, and we would be subtracting 8, so x equals a negative 8. So basically what that means, if you were to go ahead and plug in 0 into this for your x's, it would 0 out, so 0 would equal 0. Same with negative 8. If you were to plug that in and do the math, it would 0 it out. So that's why we need to get everything to the same side and set it equal to 0 and factor. Okay, so example 73 here is one where it's not in the right form to start with. So sometimes you have to rearrange terms to get everything on the same side. So since my x squared term's already on the left and positive, I'm going to move this term over here. And we want to put it in descending order. So I'm going to just kind of put it right there between the terms. Because when I move it over and I write it in descending order, I would have x squared minus 7x plus 10 equals 0. Now we will factor this. So remembering our rules for factoring, since it's a positive 10, you know you're using same signs to make the middle term. I know 2 times 5 is 10, and if they're both negative, that would make that negative 7. So I set up my 2 parentheses for the factoring, setting it equal to 0 still, bringing that down. We split our x's apart, and we plug in negative 2 and negative 5. Then remember, you're going to use each factor because they both have x's in them. So x minus 2 equals 0. and x minus 5 equals 0, and solve. So I'd move 2 over, so x would equal a 2, and I'd move 5 over, making it positive, so x would equal a positive 5. I didn't say it above, but in WebAssign, it'll say x equal, you have a box, and it'll say enter your solutions in a comma separated list. So you'd write like 2, 5. Example 74. So example 74 here, it's not all in the same order, or on the same side rather. Since this is a positive 4x squared, I know moving this over to the right would be one less thing to move, but since it's positive, personally, I would still move everything from the right to the left. And so I would have 4x squared. And if I subtract that, that'd be a negative 9x. And if I added that on the right-hand side, it'd be a plus 2 on the left, zeroing out that right-hand side. You may need to come up here and kind of use some of this space up here to work with this one, because we need to go through our factoring steps. And in this case, there's not a GCF. So unfortunately, we do have to work with the form front. So remember, this would end up being a slide and divide type factoring. So you would slide your 2 to the, or your 4 to the back to that 2. And we would create that temporary polynomial of x squared minus 9x plus 8 equals 0. Then we will go ahead and factor this temporary polynomial, right? So I'm going to come up here and do that. So I split my x's apart, and I'm using same signs to make a negative 9. 1 times 8 is 8. If they're both negative, that would make that negative 9. So I would plug in minus 1 minus 8. So remember, you slid your 4 to the back to make the temporary polynomial. So these are not my factors yet. If you were to go back through and FOIL that, x times x is not 4x squared. So just another reminder of factoring. You have to do your divide step of slide and divide. We slid and multiplied, now we're dividing. 4 cannot go into 1 nor reduce, so we just pull 4 up in front of that x. And we could reduce this. 8 divided by 4 is 2. So we have found the factors. Now we can set each factor equal to 0 and solve. So 4x minus 1 equals 0, and x minus 2 equals 0. So I'm going to add 1 over. So I get 4x equals 1 and divide by 4. So x equaled 1/4. And here x equals 2, a positive 2 when you move that over. So your two solutions are 1/4 and 2. Technically, I just want to kind of point this out. When you solve this, since the whole point is to get x by itself, you don't necessarily have to pull that 4 up front. Obviously, when you're factoring, it's not a, I'm going to go ahead and call that 2 actually. It's not where you're solving. Yeah, if it wasn't an equation, we would want to definitely show it like that. But since you know you're solving for x, you could have left it in that form and said x minus 1/4 equals 0 when you move it. You get the same thing. I don't generally do it like that just because it's not bad practice to solve an equation entirely. And then that way you never forget to pull the 4 up front if you're only factoring. But if you recognize that, I know some students always say, well, why can't we just set that equal to 0? Well, you can. If that is confusing, then just finish your steps out in its entirety and solve. So another example, example 75. I want to get everything to the left-hand side. So since 3x squared is positive over here, it's my biggest exponent, I like to keep everything over there. And I'll be subtracting 5. I can't really show it yet, but I did move this under its like term because we happen to have a like term. So 4 minus 2, when we move that term over, is a positive 2x, but then I don't have anything to subtract 5 from, so I just write minus 5 there in the end. So this would be another example of a problem with slide and divide. I highly recommend you pausing this video and giving it a try because it's very much like a repeat of the last example. So you would be sliding your 3 to the back and you get x squared plus 2x minus 15 equals 0. I'm using opposite signs to factor that 15. So 3 times 5 is 15. I have a negative 3 and a positive 5 that we would need to use to make a 2. So hopefully you have paused this and went through factoring on your own. We will go and put our 3 back in for our divide step of slide and divide. So since this reduces, this would be like saying x minus 1. And this you can pull up in front, that'd be 3x plus 5 equals 0. So we have to go through those steps to be able to set those factors equal to 0. So I have x plus 1 equals 0, and 3x plus 5 equals 0. So when I get x by itself here, I get x equals a negative 1. Here you'd be moving 5 over first, so 3x equals a negative 5, and then dividing by 3, so x equals negative 5 over 3. So those would be my 2 solutions for number 75.